Have you ever wondered what does a three-phase mean? You usually see this in equipment descriptions. What does it mean? So sit back and relax as we will tackle three-phase electricity on our next video. In electricity, the phase refers to the distribution of a load. What is the difference between single-phase and three-phase power supplies? Single-phase power is a two-wire alternating current (AC) power circuit. Typically, there is one power wire, the phase wire, and one neutral wire, with current flowing between the power wire, through the load, and the neutral wire. Three-phase power is a three-wire AC power circuit with each phase AC signal 120 electrical degrees apart. Residential homes are usually served by a single-phase power supply, while commercial and industrial facilities usually use a three-phase supply. One key difference between single-phase versus three-phase is single-phase power supplies are most commonly used when typical loads are lighting or heating. Three-phase is that a three-phase power supply better accommodates higher loads. Electric utilities generate and distribute electricity using three-phase power. To understand three-phase power, we need to understand phasors. Phasor diagrams can be used to describe all AC voltages and AC currents. Three-phase power consists of three AC voltages that are connected together. At each moment in time, each of the voltages is described by the real component of its vector in the phasor diagram. This creates three sine waves that are offset from each other by 120 degrees. Let's call these phase 1, phase 2, and phase 3. We can think of each phase as an AC voltage source and a light bulb. Another advantage of three-phase power is that it is much easier for electric generators to produce electricity if a steady constant output of power is required. This is why AC electricity is called alternating current. Because the current of the electrons alternates in direction backwards and forwards. In this sine wave, you can see that the electrons are stationary at the start, in the neutral zone, and then the speed increases through the positive half, all the way up to the maximum, and then it begins to decrease all the way back down to the neutral when no electrons will flow again. After this comes the negative half, where the electrons speed up to the maximum point, and then they begin to slow down again until the magnet has completed one full rotation, where this will then repeat. This complete rotation is known as a cycle. And the number of cycles per second is called the frequency, which is measured in hertz. You've probably seen 50 Hz or 60 Hz written on your electrical goods. This means that the generator of the power station is completing a full rotation either 50 or 60 times per second. So the direction of the current is therefore also changing, 50 or 60 times per second also. When it is written on electrical products, this is just telling the user what type of electricity the product should be connected to. Three-phase became widely accepted. Now in the real world, a more practical application is the power electrical induction motors and other commercial and industrial equipment, as three-phase will provide a lot more power to these items, meaning you can pump water higher, or you can run motors faster. Power is generally generated and distributed in three-phase. And transformers are used to change the voltage. The lift motors and air conditioning pumps will need three-phase power, but the computers and office equipment will need single-phase power. So they distribute three-phase power up the building and they draw off from this as needed. The same occurs with the distribution of electricity across a city. I hope we learn much about three-phase electricity. Do not forget to subscribe and like the video. Again, greetings of peace.